Hello there. Today we'll be doing detect squares. This is our last math and geometry problem. This is a pretty interesting problem, number 126. So what is this problem? This problem is to find out how many ways we can get squares. So basically we get one item and we find out how we can get all these points together and create a square. So one way to do it, when we went over Neetcode's videos, is to get a diagonal point from this particular point and then look for the two other points because they are of the same distance. Another way to do this actually is to look to the same level. If we limit the search to the same level, we don't have to go to this point, and this point. We just go to a single point and then we look there and create a square and multiply these 3 points together to get the number of squares. So let's do that instead, looking at each particular point, getting the number of different ways we can get squares from this particular point. Let's say this detection count. And so this particular code is very slow. Let me show you right now the one that Neetcode had, because we go through all the points. And now we're going to limit that search to a fewer points. That way we have a much faster algorithm. See, this is like 600 milliseconds, 1000 milliseconds. Let's go do the new one. All right, let's go reset this and confirm. And here we go. Let's go. So what we're gonna do is set all the points again. Equals default dict at int, and we're gonna set another one to y points equals to default dict at set. So with that, we can collect all our y points. So x and y is going to be our equal to points, and self dot points, a tuple of x and y, plus equals 1. And then self dot y points at y dot add x. So at this particular y, we can get these particular x's. So let's do the search. So query x and the y point in the query, in the points. Let's do square count equals 0 for x in, so this is for all the x's in on the same level of the y points. So now we can look if the qx, the query, is equal to the x found, then continue. Else they are different, so we can add them. Now we can add the sums together. So square counts plus equals self dot points x and y times self dot points qx y plus def. This is to be below the line, and the other one is to be above the line, because there are two different ways of getting there from the y. So we just need to add those together. So plus, oh, we need a separate line for that. Self points x and y times self dot points, same thing, qx y minus diff, and times self. Oh, there's a problem here. This is supposed to be a tuple. This is x and y minus diff. Oh. And we're done. That's it. So now we can just return the square counts. I don't know if this syntax is okay because this is my first time doing this type of syntax where I put this on a separate line. Maybe we just do this. Okay, looks like it's accepted. There's no syntax error here. And I think we're ready to go. Okay, it's slightly faster, but okay, let's run it one more time. This is really odd because it was much faster before. Yeah, there we go. Anyways, that's how we can solve this particular count squares problem. Detect the number of squares that is relative to that particular point. That way we limit our search space. Anything else? No, I think that's it. So if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I will see you in the next one.